Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Maliha Husna binti Suhaimi, metric number 1170866. My supervisor is Professor Madya Dr. Muhammad Hafiz bin Muhammad Isa. My proposal title is The Effects of Polymer Concentration on Polyethersulfone Nanoclay Membrane for Dyes Removal. Polyethersulfone nanoclay membrane is the one of the example of polymer nanoclay composite, whereas PES has been selected as the polymer. Same goes to my proposal. The PES has been selected as the polymer because PES is classified in asymmetric structure group or a thin film structure, which will give high in selectivity and high in permeability. So, two common methods used in membrane production is the interfacial polymerization technique or IP technique, and the second one is the phase inversion technique. However, the IP technique is the most well-known method used by the researchers. There are three objectives in this study, which is the first one is to modify the performance of the membrane by changing the polymer concentration. The second one is to fabricate phase nanoclay membrane for methylene blue dye removal through phase inversion technique. And the last one is to observe the characterization of the phase according to the different polymer concentration via FGIR and FESM. So the scope of this study is synthesizing a membrane by referring to a new dot formulation consisting phase nanoclay with different polymer concentration. Next is the fabricating process of membrane sheet by soak into the ethanol and hexane, followed by drying at the room temperature. Next is observing and evaluating the performance of the membrane with different polymer concentration by PWP test and percentage rejection dye removal. And the last one is characterizing the membrane via FGIR and FESM. So for the problem statement, based on a study conducted by the Yasin, he said that many industry and factories that use dye for their products will give several impacts toward the environment, such as the textile industry. They flow out the effluent containing the dyes into the water sources, leading to the water pollution problem. So this is will result to the high demand of an efficient membrane. So this study is conducted is to modify the properties of PES by observing the effects of polymer concentration in order to produce an efficient membrane for removal of dyes in the water sources. In literature review, many studies use polyethersulfone as the polymer with majority concentration between 17 weight% to 21 weight%, because within this range, the nanofiltration membrane will be produced. The NF membrane is attractive towards the polyethersulfone polymer. However, PES polymer consists of hydrophobic nature, which will lead to the falling membrane effect, which is not good for the membrane performance. So, the purpose of additive is to increase the performance of the membrane, such as the surfactants and the nanoclay additive. So, it shows the result in improvement for dyes rejection. For the materials, polyethersulfone is used as the polymer, nanoclay is used as the additive, fluoronic F1O8 and CTAB used as the surfactant, NMP, ethanol and N-hexane as the solvent, and the last one is the methylene blue as the dyes. So, in methods, it consists of 4 steps, which is the DOP solution preparation. The second one is the membrane casting. The third one is the evaluation of the membrane performance. And the last one is the characterization of the membrane. So before the preparation of DOP solution, we have to create DOP solution formula. Whereas in the formula, it contains the polymer concentration, the solvents, the additive, and the surfactant. So in the DOP solution preparation, the solvent, which is the NMP, will be heated until 50 degrees Celsius and followed by the addition of the PES polymer with variety of different concentration from 17% to 22%. Then, the surfactant and the additive will be added into the solution, and the solution will be stirred until a homogeneous solution is obtained. So, in the membrane casting, the doped solution will be poured onto the glass plate and will be cast using the casting knife that has been set up into certain measurement of thickness. Next, the membrane will be immersed into the ethanol followed by the N-hexane. Then, the membrane will let to be dry at surrounding for at least 24 hours. So, the evaluation of the membrane performance will be done with two tests, which is the first one is PWP test, stands for pure water permeability, and the second one is the percentage rejection of dyes. Both tests is to measure the flux, whereas the PWP test is one to measure the water flux, and the percentage rejection of dye is one to measure the dye flux. So for the characterization of the membrane, the morphological structure of the membrane will undergo the FTIR instrument and the FISEM. So for the expected result, it is expected that the nanofiltration membrane will be formed in this study because nanofiltration is very attractive towards the best polymer. Next, it is expected that by using 21 weight % of polymer concentration, it will produce the best nanoclay membrane because the 21 weight % of polymer concentration will produce the nanofiltration membrane. So next, for the PWP test, will expect to increase when the polymer concentration is increased. The rejection percentage of dyes will also increase approximately to 99.9%. Thus, it is expected that the polymer concentration will affect the best nanoclay membrane for dyes removal. So this is the proposal milestone and the Gantt chart for my final year project. Next is the reference that I used to refer in order to finish my proposal. So that's all for my slide presentation. Assalamualaikum and thank you.